dendritic erosion created by flowing water.
They're not.
And electric arcs exploding across a surface can produce sinuous channels that also resemble fluid erosion.
NASA will never tell you the truth, never.
But there are differences. In electric discharge to a solid surface, the electron pathways frequently create dark spotting, or chains of craters, running along the channel floors or close by. The presence of crater concentrations in relation to surface channels offers a fundamental test of the electrical hypothesis.
Correct. Look at that.
In electric experiments, we also see coronal streamers radiating perpendicularly from the primary discharge channel.
Correct.
Both the cratering and the coronal discharge are keys to a new understanding of the Martian surface.
All you need is the electromagnetic vehicle to. So all you have to do is bring
The
those
electric
tuberculosis.
arcs cut the great
So-
channels on Mars.
Niagara Valleys.
Nergal-Vallis is some 3 miles or more in width and 250 miles in length. Yes, it did look like a dry riverbed when
It's
first
not.
seen by the Mariner 9 mission in 1972.
We
But
got
the original
hexagonal
confidence of
shape.
planetary scientists soon gave way to doubts, then to contradiction. The
Columbia
river
River.
can take many twists and turns along its path, but its tributaries will not look like the blunt alcoves of Nergal-Vallis.
Exactly. Look at that.
Martian channels exhibit the predictable features of an electric scar. Rotating cylindrical arcs, sputtering along the primary discharge path, produced scalloping of the channel walls, with sharp angular projections that are inconsistent with fluid flow.
Totally
The same
correct.
process left overlapping craters and alcoves that make no sense in terms of familiar erosional patterns. We see virtually identical craters, alcoves, and sharply cut, stubby gouges along the Nidi-Vallis.
Huh?
Numerous other Martian rills underscore the same enigma, and the unanswered questions grow year by year.
Look at two identical craters on each side of the electric arc to wood, Niagara Valleys, tributaries. Nah, no collapse lava, anything.
Planetary scientists identify depressions such as these as collapsed lava tubes.
There's not a single volcano anywhere around there.
Lava tubes form as flowing molten rock cools and hardens at its surface, insulating the lava below so it continues to flow in a tube that eventually empties. When an empty lava tube collapses, the result will be an entrance to a lava tube cave.
Right.
A good example is Barker's Cave in Australia. So a cave entrance is the first thing to look for on Mars. The second thing to look for is a rubble field created by a collapsing roof.
Right.
And a third thing to look for is abundant outflow, since the emptying of a lava tube requires an outflow region.
None of that
In
here.
reviewing innumerable instances of claimed lava tube collapse on Mars, we find no cave entrance, no rubble field from a collapsed roof. and no outflow. The depressions stand alone, with literally nothing to support the theoretical interpretation. Like any fluid, lava flow follows topographical relief, always running downhill.
This
The
thing
channels
goes up
seen here
here.
change direction randomly, in apparent disregard for topography. They make 90-degree turns, unrelated to surface gradients.
Exactly. Mm.
And they also cross over each other with no disturbance of either.
Imagine.
These depressions cannot be collapsed lava tubes.
No.
But what are they?
Plasma.
What you see here is not the planet Mars. It is a surface affected by a very high voltage but microamp current, creating a complex of gouges and craters. Again, in electrical terms, craters and channels are inseparable companions. In responding to the mysterious channels and depressions on Mars, many planetary scientists thought they saw spreading and fracturing. And indeed, evidence of fracturing is present on Mars, as seen here.
But no
Here,
fun.
there are no associated craters or crater chains,
Exactly.
and the nature of the stresses acting on the surface is an open question.
How that happen?
Planetary scientists think in the same terms when considering the region of Avernus Collis. They identify
Wow.
the channels as cracks or fractures.
Yeah.
But why the concentrations of craters and crater chains? A rotating electric arc traveling across the surface can alternately sputter forward to produce linear chains of craters, or advance on a continuous path to cut channels as if by a router, with uniform depth and parallel sides.
There you
Seen
go.
in laboratory experiments with electric discharge channels, here the channel width will be the width of the rotating arc at its contact with the surface.
Correct. Totally correct. Look at that perfect match.
The question of crater formation on rocky planets and moons must be reopened. The impact explanation would mean it's only necessary to
Yeah.
count craters in order to calculate the
Yeah,
age of
but-
a surface.
Shape in geometrical pattern, impossible.
But electric discharge on a hemispheric scale could quickly create a surface that looks 1 billion years old to those counting craters. Plasma scientist Dr. C.J. Ransom of VivaSat Laboratories conducted a series of experiments with electric arcs. Electric discharge produced surface cratering patterns closely resembling those observed on planets and moons.
Now
Even the
we're
surface
talking.
darkening in central bumps or mounds of so many craters on Mars
Look
were present in
exactly.
the laboratory experiment. Electric arcs can also produce cratering patterns that could never be produced by impact.
Correct.
Complex terracing of crater floors and crater walls are a common effect of a rotating electric arc or discharge streamer. Across the surface of Mars, we observe countless examples of exotic terracing. Impact theory was never able to resolve the mysteries. So-called bullseye craters, with a central crater inside a larger crater, are surprisingly common on Mars. Could this be a rare accident? That explanation is reduced to absurdity when two such craters are seen side by side. In fact, several bullseye craters appear within the same region of Mars. But an ionized discharge path of lightning does allow for subsequent discharge along the same path. The Bullseye Crater is a logical extension of the Electric Monk. And when it comes to improbable events side by side, these two craters with central peaks each terminating in another crater will certainly never be explained by impact. Impacts do not create hexagonal craters. But look closely at this region of Mars, and you'll see several hexagons. An observed form taken by rotating plasma, as seen in the planet Saturn's electrified polar hexagon.
Now we're talking. I told you.
In an extended discharge, systematic cratering, pitting, or etching can be the norm. That's why in industrial applications, electric discharge machining can achieve exceptionally dependable results.
Correct.
The microscopic pitting of electric discharge can give a consistent depth and a remarkably smooth surface, despite the fact that the surface is entirely constituted of craters or pits. The same effect can be observed on seemingly smooth surfaces in the northern hemisphere of Mars, surfaces that have been excavated miles deep.
Same thing on the moon, Earth moon. Hexagonal craters, square.
But look more closely with the help of recent high-rise images. And smooth surfaces are revealed to be nothing more than fields of small, densely packed craters.
Nice smooth rim on the craters.
The baffling crater field seen here, like so many others on Mars, is a perfect counterpart to an electrically machined surface.
Now we're talking.
And don't underestimate the scale of this dilemma for planetary scientists.
Show Iapetus, the moon. You see
We
that?
witness the pattern at both the low points and the high points on Mars. From the bottom of Zunil crater in the depressed northern hemisphere,
That is big, man. Olympus Mons.
to the highest point on Mars, the summit of towering Olympus Mons. Here, no grasping for conventional explanations such as a dune field could possibly account for what leaps out at the observer.
Look at that.
The baffling crater field seen here, like so many others on Mars, is a perfect counterpart to an electrically machined surface.
Correct. Look at that, man. Look like cell walls on the skin on animal cell. Dendritic form. There you go. Look at that, man. That's just incredible. That's what you see on Dion, Dr. Bergrun's book. Look at that. Secondary streamers.
More than 2 centuries after Benjamin Franklin flew his kite, the origin and behavior of lightning continues to amaze and to puzzle the lightning specialist. Lightning will occasionally imprint its distinctive form on terrestrial surfaces.
Look at that, man. On a sidewalk,
And
on a
even on the
person.
skin of humans.
Whoa.
In the laboratory, the counterpart to lightning is the Lichtenberg figure, perhaps the most common and fascinating form taken by electric discharge.